What's happening, guys? Scott from Hornet's Nest. Welcome back to episode 25 of Tutorial Tuesday. As always, so good to see you. And in today's episode, I want to show you how we built this IFEI module. It's part of the low instrument panel module, but we're going to be focusing on the IFEI and the back wiring and the engineering behind it. Awesome module, big module. And the thing is, it's incorporated every bit of knowledge that we've learned from episode 1 through to 24. So it's the perfect time to build it. We've got screens, we've got push buttons, switches, knobs, we rotate it around, big, large 3D prints, circuit boards, wiring looms, the whole lot. So it's gonna be a 2-part series. It's gonna be part 1 today, when I'm gonna show you how we painted, engraved, wired it, assembled it. And then next episode, I'm gonna show you how to connect it to your computer and make it exportable. Because it's a little bit different to all the other modules. DCS doesn't natively export the IFEI available for users to use, but I'm gonna show you how to copy and paste a couple of lines of codes, get it working, and then you're gonna be on your way to having a pretty cool module. But before we get into it, we've got a competition to announce. For those of you that participated in the Christmas competition, today's the day. And for those that are wondering, what Christmas competition did I miss out on? It is for those viewers that stay to the very end of an episode. I want to reward those that take time and be part of the channel itself. So I'm going to be always dropping little Easter eggs throughout episodes leading up to competitions or giveaways. So yeah, it's not always going to be the end. It could be the beginning, it could be the middle. But for the Christmas competition, 68 of you entered. I'm just looking at the competition page here, and 2 of you are going to walk away with the IFEI module itself with the buttons and the circuit boards. You're going to need to go print the low instrument panel and the rest yourself. So first up, in no particular order, we've got William M from Camden, United Kingdom, and Gordon R from Sonoma, California in the US. Both of you, thank you so much. It means the absolute world that both of you, as well as everyone else that joined the competition, wanted to be part of it. It's so cool. I never thought that would be a thing, but here we are. So let's get into it. Let's show you how to make this IFEI. Let's head over to the workstation now. Let's build it, and then we'll be back here to show you how to wire it all up. Alrighty, let's get into it. Let me show you how I built this IFEI. In front of me, we have a completed faceplate for it, and it's made up of 3 components. We have a text layer, a light diffusing layer, and a base layer. Now, most panels, the text layer and the diffuser will be glued together. That will be screwed to the base plate to create a panel assembly. Then that assembly will be screwed using Zeus fasteners to the cockpit itself. Now, this is a bit different because all of these 3 are glued together as one whole piece, and it's painted as one whole piece. So how did we go about that? Well, I uploaded the files to Lightburn, I sent them to my laser, and then I went and cut them out. I'm using 2mm white acrylic for the text, I'm using 4.5mm clear acrylic for the light diffuser, and I'm using 3mm black acrylic for the base layer. Now you're probably asking, does metric material impede on the accuracy of the Open Hornet design, which is imperially designed? No, because if you have a look at this, the thickness of this is 9.5mm thick. Open Hornet is intending 3/8 of an inch, or 9.525. So we're 0.025mm off of the actual thickness. So you're not gonna have any issues at all. So once that was all cut out, we then came back upstairs, we started gluing the text and the diffuser together using Acribond and making sure that it was all nicely aligned, and you'll notice that there is a clear offset in the openings between the diffuser and the text plate. That is intentional. Your laser cutter did not cut it wrong. Now, once that was done, I then went and glued that sub-assembly onto the base plate. And again, you want to make sure it's all nicely aligned because it's glued. You're not going to be able to have that wiggle room that you get with screws. So that was the front face done. We popped that to a side, and then we started printing the bezel and the buttons. The bezel is this little ladder looking piece here. It's got some finger guards and it rests in that slot on the faceplate, and it just protects the buttons and holds them in. Same with these button bases. They are what create the contact between the legend, or the part that your finger comes into contact with, and then the tactile switch at the back on the circuit board. These are printed out of resin on my Saturn II 3D printer, and I'll create a link to files for the light sheet scene that I used, so you can go and print them as well. Now, I initially started printing with the bezel flat because I wanted to have nice layer support on the build plate. It was going to be solid, it was going to be good, but it's just too hard and too fragile to remove with a spatula from your build plate if you don't have your settings quite right. So instead, I built it on the side, I put some supports in, and it was beautiful. And with medium to light supports, you're really not gonna have any bad deforming on that exterior surface. Once these were all done and all the push buttons were done, we then went and laser cut out the button legend plates, and I did a jig around them, and I'll upload that jig file as well for you. That way you can either use that as a jig to engrave your buttons, or you can be inspired for maybe a jig you want to create. And then that was all done. I then took it downstairs and I started painting them with Rust-Oleum flat black. Now it's a pretty close black to the lusterless black that we're looking for, but it's not quite there. It is a bit dark in my opinion, but that's fine, because what we did was we did 3 to 4 coats, really gave it some good layers so no light leaks through. And then I hit it with 2 to 3 light misty coats of Dulux matte clear coat. And then that's given it that beautiful lusterless look, and it protects it from any scratching. So everything's painted, everything's looking good. Now we just got to engrave. I used that jig from before to then set up in my laser cutter to engrave the legends to make sure that they are perfectly aligned. And yeah, if you get something this small and you try align it the old-fashioned way on the laser, you could probably get it there, but you're not going to be able to make repeatable engraves. Like, it just moves around too much. So the jig really helped with something small like that. When we went to go engrave the text plate, that was fine. We put our piece of paper down, we marked it out, we shuffled it around, and then we engraved. And it's heavy enough to survive, but with such light legend plates, you want something certain when you're engraving that. So that's it, and this is where we find ourselves, up here in the studio, ready to assemble it. So first things first, let's go and get this bezel put in. Place it on the top, and we're going to use these tiny little screws with these tiny little nuts, and they're going to hold it nicely in place. There we go. And now I can't remember if I mentioned it before, but these light holes where the diffusing comes from, they were blue tacked. I put blue tack mask in there, that way I could spray the entire piece and not have to worry about that diffuser getting even more diffused by the black paint. So that's why you see a little bit of like different shading in the black, just where the blue tack was masking it off. So now we've got to go install the buttons. Make sure you put them the right way around, starting off with mode. And the finger guards allow you to install it this way without having an issue with it keep popping out. And they just sit nicely in there. Go there, the PCB sandwiches it on. Now let's actually, I'm gonna pop this here, let's have a look at this PCB quickly. These PCBs that you're seeing in this episode have been kindly given to us by PCBWay. If you're looking for your PCB needs, 3D printing, CNC milling, the whole lot, they're a one-stop shop. And I love their customer service. I wouldn't be promoting them if I did not believe in them. They do an incredible service of the turnkey production style where if you don't want to solder, you don't know how to solder, you don't have that equipment, just send it all to them. They will get it all done for you. Now, all of this was done by them. I do all the through-hole soldering myself just so I can still feel like I'm doing something, but if I didn't want to do it, they would do it as well, and they do an incredible job. So the buttons we're using here are a little bit different to the ones on our AMPCD. They don't have the LEDs in them. These are B3Fs 1026s. Now, Open Hornet calls them out as a B3F 10XX. The XX is just a variable number based on its product number, and it denotes the force required to actuate the push button. The lower that last 2 digits, the less force required. Now the 1026s have a really good amount of force to them, not quite what we need. We actually do need a little bit more, but it's as close as we're gonna get for now. And yeah, I really like them. So that's what the XX is if you're seeing it on the Open Hornet files. And we spin it around, we've got pin connectors here, and then this will actually break out into these 2 circuit boards here. You've got the Absys ALE, which is the circuit board that holds the Arduino Pro Micro. And then we've got the bus master circuit board, which is one per console. And then right now it's acting as a power transfer board, but later on it's gonna be the bus connectivity. So what we're gonna do is we're gonna sandwich it all in, and then we're just gonna make sure that we've got our buttons the right way around. There we go. That's looking pretty good. And you can feel it's already got a nice feel to it. That's quite nice. And now store it face down on a smooth surface. Nice soft surface, don't scratch your hard work. And let's have a look at the lower instrument panel module. So this here is 3D printed on that big machine over there. That's the QIDI Plus 4 that we spoke about in episode 24. It's a beautiful printer sent to me by the team at QIDI. I'm overwhelmed by their support in 2024, and we're looking forward to some really exciting things in 2025. If you do want to get one of those printers, go check out the link below. It supports the channel. It tells them where you found it. And like I said in that episode, if we get enough of those clicks, even if you just want to have a look at the website, click that link. It tells them, hey, Hornet's Nest viewers like this website, and maybe we can get them into doing a giveaway for you guys. So this was printed on that. Really nice build plate. You can do it on a bamboo. You can do it on the QIDI. You just can't do it on a 225 by 225 build plate. It's just too small. Spinning it around, I've made some modifications. I've gone and actually recessed the screen area a little bit more to give it more of a slim look. And I've gone and added a bar across where the fuel instrument is. The reason for that is there's a bar here, and that was just going to leave a hollow gap. It creates dust. I don't know, it just looked a bit odd to me. Maybe there's a reason behind it, I'm not too sure. But that's what we've gone and done. I've gone and painted this as well as all the other avionics pieces in a very similar gecko color, not exactly gecko, because I wanted it to have a bit of color contrast. That way it looks cool. It looks a bit modular. And then you'll notice that I've gone and painted the interior here black. And the reason for that is if we go and put this circuit board and this module on that, it's going to go black, gray, screen, and that's going to look a bit weird. So we also did that with the circuit board. I painted the edges of the circuit board to take away that fiberglass color. So yeah, now all we got to do is start assembling this. And the reason we haven't put the faceplate on it is there's a couple of hidden screws that hide behind the IFEI, and two, we don't want to scratch our IFEI as we're working with this. So let's start installing the standoffs and let's start building. You'll notice that I'm currently not using the Open Hornet called out standoffs. They still stuck in the post somewhere. So I'm just using standoffs that I found around the house, and I'll replace them when they come in the post. Beautiful, that's looking good there. Next thing we want to do is install our screen. The screen supported by the team at BuyDisplay. It's a 7-inch TFT screen. It's the same screen family that we used for the AMP CD and that we used for the DDIs, and it's the one called out in the Open Hornet documents. So beautiful displays by them. Just, they're such a pleasure to work with as well. So that's gonna sit in there, and you can see how it's in the nice recessed gap there. So that's gonna fit real nice. And we can screw it down and hold it down with these screen holding plates. Now what I've gone and done is I've added a little bit of neoprene to the backs of them. That way it presses onto the screen and holds it nicely in place. So let's screw these in. Alrighty, the screen's in, looking good. Little trick when aligning the screen, if you're using the same display model number as this, is have the ribbon on the bottom. That way, there is no silver edge coming through this. If you have it the other way, you'll see a thick silver band on one of the top or bottom faces, and it doesn't look nice at all. And now time to install the avionics tray. Now that is gonna sit on there, and you can see I've countersunk these ready to receive the countersunk screw that goes in the proper standoff, but we're gonna have to do this for now. And then that can... And I've pre-installed the little standoffs that hold the circuit boards. There we go, and our abscess ALE would fit nicely like that there. Now I'm gonna leave it there. We're gonna head across to the computer now and finish the assembly there. I wanna leave this piece and I wanna leave the circuit board on the back of the IFEI out so we can talk about the wiring, talk about how to create that harness and how it actually connects. Otherwise, yeah, you're not gonna see a thing. So let's head over to the computer now. Let's finish it up and have a look at the interconnect so we know how to wire the IFEI to the ALE. Alrighty, now that we've built it, let's get into the wiring of it. Now, every time I think wiring, I think interconnect. The interconnect, for those that are just joining in on those episodes, is the wiring mind map diagram schematic from Open Hornet telling us how to wire the PID. And it's got some certain specifications telling us which wires to use, which connectors to use and all that. So when we get into it, I'll give you a quick recap, but for a more detailed episode, go check out the previous episode on cable management and that's gonna have it all in there for you. So let's have a look at what we're actually doing. We want to connect this IFEI circuit board to the abscess ALE. Now, for those that don't know what the ALE is, that is the almost everything board. Bit of an odd one, but that's what it really means. It is almost everything. We could almost fit everything on the IFEI board itself, but we need to break it out to fit the Arduino one as well. So that's what that is. It is just a breakout board, and we want to connect these two together. Well, how do we go do that? We are going to go reference the interconnect. So if we go load it up here on the computer, we go to our favorite folder, Open Hornet build package. It's on the very first screen, and we go open the interconnect version 10. We want to scroll down to the third page, which is our lower instrument panel, remembering that each page is its own console, the upper, the lower, the left, and the right, and the center. And then this is looking pretty familiar for those that joined us in the cable management episode. For those that haven't, a very quick rundown. Anything you see in blue boxes means it's a subsection. You've got the power supply unit subsection, you've got the IFEI subsection, you've got the AMP-CD subsection, backlighting and so forth. Those subsections have yellow boxes within them and they indicate circuit boards. Those circuit boards are connected by green lines and they are the wires, and then you've got either boxes or crescents and dashes joining green lines together. A box is a Molex connector, and a little crescent and a dash almost looks like a little Space Invaders plane. That is just a general purpose pin. It's one of those DuPont connectors or a Molex pinout. So now that we know roughly what we're doing, let's zoom on in to the bottom left of the lower instrument panel page and let's have a look at joining the IFEI up. So let's see where we are first. We are going from the left bus power, which is the top left of the screen. We connect it via a Molex connector to the HID bus master. Now that's this circuit board here. Remembering from when we're at the table, we don't need to attach an Arduino to it yet because we're not using the bus protocol on it. We're just using it as a power supply and power transfer panel. So that's that panel. And it goes via two Molex connectors into this circuit board here, which is the abscess ALE, that's that green text. Now we're looking at it and we know that we're having Arduino connected to it, so we can start making sense of some things. D15, D14, we're showing that these have Arduino pinouts, plus we've got a couple of extra grounds and 12 volts and 5 volts, etc. But how do we connect that to the IFEI? Well, it's a bit confusing if you don't know what to look for. Remembering the blue box is the subsection, so everything we need is in this blue box, we just need to look for it. The bottom left here, we see a little wiring diagram with common Arduino names on the left, and then we can assume that these on the right are switch positions or input positions. So let's start top down, let's have a look at a couple, and by the end of it, you should be on your way to be able to identify any switch and Arduino pin number within the interconnect. So let's have a look here. We are purely just focusing on the integrated fuel indicator at the moment. We've got a 4x2 jumper pin connector there, and it's got a little designator called J3. We've got positions up, down, quantity, zone, mode, ET, and 2 grounds. Well, if we look at our wiring diagram here, we can see that those names are on the right column in the middle, and we can see the little crescent and dash indicate that is a general purpose pin or a DuPont pin. So pins 1 through to 8, so we know that's what that connector is talking about. When you want to know how these are actually numbered, because we don't have 8 in a row, we've got 4 rows, 2 columns. If we draw it up on a diagram here, we go pin 1 is the top left, we go to the right to pin 2, then we go down to pin 3, 4, 5, 6, 7, 8. It goes like a little zigzag down. It's not just one big column of pins. So we know that we need to connect up to one of these pins here. So if we take our mouse and we look at the up switch, it's pin 1 on the IFEI panel, green line goes up, and then to the left, it connects into this name here, D3 SCL J34. Now you're thinking, Scott, what on earth is D3 SCL J34? Well, let's break it down and then you'll be on your way to knowing how to do the rest. D3 is the Arduino pin name that we are most commonly familiar with. Pin D3, it's a digital pin number 3. SCL is just saying that Arduino treats that as a serial clock, depending on if you're using I2C or SPI protocol, but that's too complicated for this lesson, but that's what the SCL is. It's just another name for it. J3 is jumper 3. If we have a look at the ALE, there's a little J3 at the top of this group of pins. That is saying jumper pin set 3 is what we're talking about, and then it's position number 4. Now, remembering it goes top left, top right, and it zigzags its way down, so we can count 1, 2, 3, 4. And it's got D3 written next to it as well for ease of use. So now that we know that, let's do one more. And we'll pick a slightly harder one. Mode switch, that is looking at pin 5 on the IFEI. And we can see it's got mode selected next to it. They've made it real easy for us, okay? It's not hard at all. Mode switch, we follow the green line down and it connects to D14, MISO, which is another aspect of that Arduino board if you're running different protocols, and then J4, position 3. Well, we know that J3 is this top one. We can have a look on the board, it's annotated there. J4 is referencing this pin set, and we are looking for position number 3, D14. It is as simple as that. Now you can choose how you want to wire this out. For ease of plugging in, I've gone and created a little wire harness, and it's going to connect in there like that. And then I've got them breaking out, and be creative with it. You don't have to do it as a wire harness. You can do each individual wires if that's easier for you. There is no right or wrong way to do this. Now, if we just have a quick look down, I haven't shown you that I've built this panel, but here it is here. We've got the video record panel, and we've got a couple of inputs behind it. They take up a lot of grounds. Each one of those inputs has a ground pin. But if we're looking at what we have available here, it doesn't look like it connects everything to those ground pins, because VR ground, video record ground, is mentioned 3 times, but there is only one pin mentioned when it's in J4 as the jumper pin 4 set. You don't need to splice them all to that one pin. All the grounds on this board and this bottom rail here, this horizontal one, they are all connected to the same ground plane. So if you want to break them off onto that because you have more grounds than what's annotated, feel free to go do that. Same with up here. There are 2 grounds coming out of the IFEI's panel, and they are annotated as if they are connected together. You don't need to go run 2 ground wires from the IFEI to the ALE, because on the IFEI itself, those 2 pins are joined within the circuit board. Tracing, you don't actually have to do 2 wires. So any ground that you see here, unless annotated otherwise, you can see will all connect into one. So that's the wiring down pat. We now know how to break it out. Let's get it built, let's get it assembled, and then I'm going to show you some cable looms of how things kind of daisy chain together, and then that should be it for the end of the episode. Alrighty, so that's it built there. Let's just have a look. It looks absolutely incredible. Beautiful tactile feel. They aren't glued in, but they just hold in quite nicely. It's a beautiful fit. The knob's real nice. Set in there with some set screws. Things are looking up. So let's finish the wiring. We've got everything assembled. We turn it over. If you are going to do this and you're going to turn your module over on its faceplate, just make sure you've got something soft underneath it. You don't want to ruin all that hard work by putting it on a hard table. Just have something there to absorb some of that shock. Now, what we need to do is we need to work out how this all connects. Now, if we have a look at the interconnect one more time, we've got lower interim bus power. It goes via an ABSYS C-type cable to a Molex into jumper pin number 1 on the ABSYS HID bus master, which is this one here. It's the 4x2, and we can see it's got J1. And it then goes out via jumper pin number 2 or a connector number 2. It's a Molex connector called bus number 1, and that's this one here, the 3x2, and it's going via an A-type cable into the ALE. So we're looking at a cable that joins the bus master to the A-type cable. Now, if you look at the specifications page, it's in the specifications folder, and it's the page to do with wiring and the interconnect. An A-type cable is just a 16 gauge white stranded wire cable on a Molex connector, and it's got 6 strands. And it's this little one here, and we've done some nice cable management with it to keep it nice and compact, and we've gone and relabeled it. That label up there, 4A1W question mark, I think that's an error. I've just gone and labeled it 2A1W0 because it's prior to 2A1W1. Kind of works out, do it how you want. And then we can see that bus 1 is where it comes out of, and it goes into, if we have a look here, jumper 1 called bus in. So let's find jumper 1 bus in. It's this little one here. It's got a good amount of flex. For a thick cable, it actually flexes quite well. And then we're going to go and connect that in, give it a bit of a bend. There we go. That's looking nice. Now, I know a lot of you would be thinking, where are your service loops? How are you going to fix that? It's a small cable. I'm not really wasting too much resource. But if you're doing longer cables, chuck a couple of service loops in there, a little extra length. That way, if you need to make amendments, you need to fix something, you've got extra wire there to play with. But something as short as this, I'm not too worried. And then we've got one extra cable here that I've made, and it's got the designator 2A1W12, and it's a 4 or 2x2. Now that one is going to connect the backlighting. So if we just scroll down a little bit more, we can see the backlight panels, and we're going to start connecting the backlighting together. And that's with these little cables here. They are the B-type cable, which is a 2x2, and anything that you see 2x2 generally going to be backlighting power. And we can identify it by going lower interim panel, backlight channel 1, goes through a connector into backlight in on the IFEI panel. So that cable is already installed in the cockpit, and we're going to connect into that next episode, but we're going to go out of the IFEI through backlight out, a B-type cable, and this is our identifier here, 2A1W12, into the backlight in on the video record. So if we have a little bit of a look here, it's a bit hard to see the names, but we've got backlight in on the video record here, and we've got backlight out on the IFEI panel. So we can connect these two together. There we go. Squeeze that wire a bit. There we go. And that there is everything done. That looks so damn good. I'm really happy with that. All we got to do now is attach a HDMI cable into the HDMI port, but we're going to do all that next episode. We just wanted to focus on the assembly of this. Let's just have one more look at this. That is just such a nice module. No, I'm really happy with that. That's really cool. So I hope you had a good episode. It is so good making videos for you again. 2025, I can't believe first episode done. And here we are with such a cool module. It was an all-in-one, everything. Episode 1 to 24, we did it all in one. So yeah, go enjoy the rest of your week now. Get building. Let me know if you build one of these. William, Gordon, I'm gonna send these out to you as soon as I can. Thanks for being here. It is such a privilege making these for you. As always, stay safe. Go enjoy some flight simming, and I will see you in the next episode. What's happening, guys? Scott from a Hornet's Nest. No, is that even recording? Yeah, it is. Hello. We're doing it. Episode 25, first one of 2025, and we're going well.